as promised, we're interpreting this concept of confidence interval for proportions, and we looked at calculating it in the previous video and also introduced the concept itself too. And the confidence interval is an estimate of an interval that may contain a population parameter that we're chasing. All right, and the unknown population parameter is found via some sample parameter taken based on a bunch of sample data. So we need some sample data. Okay, and yes, it's frequently quoted, I should say, as a percentage. The confidence level can be given as 90%, 95, 99, and occasionally others, but those three are the common ones. All right, and we've established all of these things. There's an example of one of the confidence intervals we calculated in the previous video. So go back to calculating confidence intervals video. So with the upper and lower boundary, that's where we're pretty sure. The amount to which we're pretty sure depends on what our confidence level is. We're pretty sure that any sample collected will fall in that range. We would expect that a certain percentage would fall in that range. So that's our confidence level, or our confidence interval. Now we're going to look at some ways of interpreting the confidence interval and some misconceptions, i.e. ways that you should not interpret the confidence interval. Okay, it does get used incorrectly sometimes, and the idea is to avoid that. Now I know it's really hard to understand, but smiley face equals good and sad faced equals bad. Alright, and here's some examples that are both correct interpretations and misconceptions, incorrect. Okay, so the first one you can see there, we are 95% confident that the interval between some upper and lower bounds, like that example for example, contains the true value of the population parameter, the thing about the population we're trying to find. So we're 95% confident that this interval has the true value in it. Okay, that's probably the most common way of talking about it. 95% confident that the interval is in that range there. Okay, that and any future samples we take, we're 95% confident that the values will fall in that interval. Another good one, we estimate and expect 95% of such intervals to contain P. Okay, so that interval, it relates to us expecting that 95% of such intervals contain the real population parameter, population proportion P. Okay, whether or not this confidence interval contains the population proportion is usually unknown, but we are 95% confident. We expect 95 of these intervals to contain the population parameter P. Okay, the population proportion in this case. It also works in different ways with other population parameters, but we're sticking with proportions because that's what our focus is here at this point. Now, what not to do. These are this is first misconception here, and a quote, there is a 95% probability that the interval between lower bound and upper bound contains the true value of the population. That is not an appropriate way of using this idea of confidence interval. It is not a 95% probability. Okay, we would expect 95% of all future samples to contain the true parameter, but that doesn't mean there's a 95% probability that it's in there. It's either in there or it's not. Okay, so we do not say 95% probability. And similarly, with the confidence interval found in this example that we did in the previous video should not be written in the following way. See how it's got the probability there, and I'll remind you of the example we looked at in the previous video. It was this one here, and we had a 95% confidence interval for regarding students who regularly use social media, primary school students, and we took a random sample of 20 and we found the sample proportion to be 0.7. We came up with a an interval of 0.499 up to 0.901. Okay, this should not be written as the probability that P is between 0.499901 is 9.95. That is not what it means. Okay, it means that we are 95% confident, or we expect 95% of such samples taken to be in this interval. That's what it really means. Okay, so it's not, the word probability at this stage is not the appropriate word, okay, because it's not true. If we visualize this concept, and if we've got 20 trials here, we can look at, see, this is the true, we don't know it, but this is the true population parameter we're trying to find. Okay, and you can see it's represented by a dotted line. So you can see that all bar one of these samples, so each of these here, these are graphs of the samples, with the sample value is the red dot, and the confidence interval you can see is spread either side. And they almost all capture the population parameter that we're chasing. Hey, that's fantastic, isn't it? And this is, I mean, this is what we're expecting anyway, with a 95% confidence interval. Okay, that's what we're expecting. And you see there is one there that doesn't. Okay, it doesn't. There's daylight there. See? All right, so it don't get there. But you know, that's 19 out of 20 that do. And 19 out of 20 is 95%. Okay, so that's a visual way of considering it.